Hello everyone, it is my pleasure to welcome you to Exam Lens for this lesson session in chemistry. It's nice to have you around. Thank you for joining in the lesson session. The topic is soluble and insoluble salts. Soluble and insoluble salts. I'm your regular host, Mr. Otaibe. Let's kick off with the introduction of the lesson that will expose us to the meaning of soluble and insoluble salt. A soluble salt is a salt that dissolves in water or mixes with water to form a homogeneous mixture. Examples of soluble salts are sodium chloride, whose formula is NaCl, and of course we also have barium nitrate, whose formula is Ba bracket open NO3 bracket close and 2 outside. On the contrary, an insoluble salt is a salt that does not dissolve in water to form a homogeneous mixture. So you can see that the meaning of insoluble salt is the opposite of that of soluble salt. Examples of insoluble salts are silver chloride, whose formula is AgCl, and of course we also have calcium carbonate, whose formula is CaCO3. Now let's analyze this artistic impression that will help us appreciate the idea better. We have two containers. The first one contains an insoluble salt, while the second one contains a soluble salt. In the first container, the salt introduced, which is an insoluble salt, fails to dissolve in the water. It does not mix with the water. Instead, it settles to the bottom of the container to form a deposit. And at the end, we now have two phases in the mixture. We have the liquid phase, which is the water, and the solid phase, which is the salt. And a mixture that has more than one phase is called a heterogeneous mixture. In essence, insoluble salts form heterogeneous mixtures. They do not form homogeneous mixtures. Then on the contrary, for the second container, the container contains a soluble salt. And when the soluble salt is introduced into the water, the soluble salt mixes with the water in such a way that both form a uniform composition, a uniform content, so much so that you can see only a single phase. The soluble salts have dissolved in such a way that it appears that they have disappeared. The particles have disappeared. And so a mixture in which the content all exists in the same phase, in a single phase, usually a liquid phase, is called a homogeneous mixture. And so soluble salt form homogeneous mixture. Note, salts that dissolve in water to a small extent are said to be sparingly soluble. We have some other salts, when introduced into water, they dissolve to a small extent. They dissolve only a small portion of them, while a large portion of them remains undissolved. Such salts are called sparingly soluble salts. Remember the term sparingly soluble salt. Sparingly soluble salt. We don't have sparingly insoluble salts. So the right expression is sparingly soluble salts. Sparingly soluble salts are classified or considered as insoluble salts. So at the end of the day, we place them in the class of insoluble salt. They are considered as insoluble salts. We now make progress to the next section of the lesson, talking of principles used for identifying soluble and insoluble salts. How do we recognize a soluble salt? How do we recognize an insoluble salt? We have some set of principles with which we recognize a soluble salt and an insoluble salt theoretically. And we want to run through the set of principles so that we become acquainted with them. We are taking the first one, and it says all liposomal salts are soluble. There is no exception. But then, what are liposomal salts? Liposomal salts are salts in which we have lithium, which is Li, potassium, which is K, sodium, which is Na, or ammonium, which is NH4. So any salt that contains Li as a part of the salt, usually the first part, or K, or Na or NH4 is automatically a soluble salt. To that effect, examples of these salts are lithium bromide, potassium carbonate, sodium chloride, ammonium sulfate. So you can see that each of them contains a member of liposomes, and whenever a salt contains a member of liposomes, the salt is automatically a soluble salt. Then we now move to principle number 2, and it says all nitrate salts are soluble. Again, there is no exception. What do we mean by nitrate salt? Nitrate salts are salts that contain NO3 group, NO3 minus, which is called nitrate ion. So any salt that contains NO3 in its formula is a soluble salt, and we don't have any exception. Irrespective of the other part of the salt the NO3 is combining with, the salt is a soluble salt. And so again, examples of these salts are barium nitrate, magnesium nitrate, silver nitrate. You can see the nitrate group in each of them. We now make progress to number 3. Number 3 says all sulfate salts are soluble except their Baleka. Take notes, we have exceptions for these. And when we say sulfate salt, we mean salts that contain SO4 2- group, which is called sulfate ion. So whenever a salt contains SO4 in its formula, then the salt is a soluble salt, except if the first part of the salt is either barium or lead, that's Pb, or calcium, Ca. Barium is Ba. So if any of these metals is present as the first part of a salt combined with SO4, the salt will be insoluble. But when we don't have any of these metals present in a sulfate salt, as in the SO4 is combined with other metals or another group, then the sulfate salt is automatically a soluble salt. Examples of these salts are, we have the examples in 2 categories. We have soluble sulfates, which include copper sulfate, mercury sulfate, iron sulfate. You can see that any member of Baleka is not present, so they are soluble salts. But when you now have a member of Baleka present, then the salt becomes insoluble, and that's why insoluble sulfates include barium sulfate, lead sulfate, and calcium sulfate. You can see that each of them starts with a member of the Baleka code, and whenever you have a member of the Baleka combined with SO4, the salt is insoluble. We now come to number 4. Number 4 says all chloride salts are soluble except their silemeku. A chloride salt is a salt that contains a chloride ion, and we recognize them by the presence of chlorine in their formula. And so whenever a salt contains chlorine, the salt is a soluble salt, except if the salt is having the first part as any member of silemeku. And when we say silemeku, we mean silver, then lead, mercury, or copper 1 ion, copper 1 ion. Please take note, copper 1 plus, not copper 2 plus. Copper 2 plus is soluble, is not among the exception. It's copper 1 ion that is an exception among others. And so copper 1 chloride is insoluble. And how do you recognize it as a formula? CuCl, the one that carries only 1 chlorine. But the one that carries 2 chlorine, CuCl2, that one is copper 2 chloride. That one is soluble in water. It's copper 1 chloride, which contains only 1 chlorine that does not dissolve in water. And so, as far as a chloride salt does not contain silver, lead, mercury, or copper 1 ion, it is a soluble salt. But when any of these is present as the first part of the chloride becomes an insoluble salt. And so, to that effect, examples of soluble chlorides are zinc chloride, copper 2 chloride, then you can see silver chloride. Then, while the insoluble chlorides include silver chloride, lead chloride, mercury chloride, then copper 1 chloride. Take note, copper 1 chloride. Then we now come to number 5. Number 5 says all carbonate salts are insoluble. Please take note, insoluble for the first time. Insoluble except their liposomes. So any salt that contains a carbonate ion, that's CO3 group, salts that carry CO3 group are called carbonate salts. And so they are generally insoluble except when liposome is present, a member of the liposome. Yes, so if the carbonate contains lithium, potassium, sodium or ammonium, it will be soluble, because any salt that contains these 4 things, any of these 4 things, is a soluble salt. So if they are present along with a carbonate group, the carbonate is soluble. But if none of them is present as the first part of the carbonate is an insoluble salt. And so, to that effect, soluble carbonates include lithium carbonate, potassium carbonate, sodium carbonate, and ammonium carbonate. You can see that they contain members of liposome group. Insoluble carbonates include magnesium carbonate, lead carbonate, barium carbonate, because none of them is carrying a member of liposome. We now come to number 6. Number 6 says most other salts, that is other classes of salt not mentioned above, for example ethanoids, phosphates, iodide. So any class of salt not amongst the ones we have recognized so far, they are insoluble. Other classes of salt in chemistry outside the ones we featured in this analysis, they are insoluble except when a member of liposome is present in the salt. And so examples of these salts are, for the soluble members of soluble salt of other classes include potassium ethanoate, then ammonium phosphate, then sodium iodide. They are soluble because they have members of liposome in them. But if members of other classes of salt do not have any member of liposome, then they will be insoluble. And that's why calcium ethanoate, insoluble. Magnesium phosphate, insoluble. Then silver iodide, insoluble. And so we want to take note of this. So we now come to the past question section. Let's review some past questions to digest what we've learned. The first one says, the following salts are readily soluble in water except... Now, we said all carbonates are insoluble. All carbonates are insoluble except their liposome. And if you check the carbonate here, is copper carbonate. Copper is not a member of liposome, and so copper carbonate is the answer. And so we acknowledge our answer as option D. We now make progress to question number 2. Which of the following salts is readily soluble in water? We said all nitrates are soluble, and so lead nitrate will be the correct answer, making option B correct. Then we make progress to question number 3. Which of the following salts is insoluble in water? Now we said all chlorides are soluble except their silemeku, and silver is one of the members of silemeku. So the answer is silver chloride. Yes, silver chloride is correct. Then question number 4 says, which of the following chloride is insoluble in water? Silver chloride again. So that's option A. So we acknowledge option A as the correct answer. Then we now come to question number 5. Question number 5 says, in which of these groups will all the substances be insoluble in water? If you do your analysis very well, you see that zinc carbonate, barium sulfate, silver chloride, they are all insoluble. So option E is correct. Question number 6 says, which of the following compounds is the least soluble in water? In other words, which of them is insoluble? And so, remember we said all sulfates are soluble except their Baleka, and calcium is one of the members of the Baleka. So, calcium sulfate is insoluble, making option B correct. Question number 7 says, calcium tetraozosulfate 6 dissolves in water partially, and it is thus, we said salts that dissolve in water partially are called sparingly soluble salts, making option B correct. We now go to question number 8. Question number 8 says, a metal that forms soluble triazosulfate 4 salt is... That should be potassium because it's a member of liposomes, and any member of liposome when present in a salt makes the salt soluble. Question number 9 says, which of the following is a soluble salt? I don't need to analyze. Sodium bromide is the answer because sodium is a member of liposome, and liposome always makes salt soluble. Homogeneous mixtures are formed by insoluble salt, wrong. Sparingly soluble salt, wrong. Soluble salt, the answer is soluble salt. Soluble salt form homogeneous mixtures, while insoluble salt form heterogeneous mixtures. And so that's the size of the lesson. Thank you for learning with Exam Lens. I'll see you again in another lesson session where we shall be engaging something new on a different subject platform.